You will get the most from any Systems to Win video when you launch it from its video homepage.
Your Systems to Win process improvement tools come with several time study templates, each with their own reason for being and ways to observe a process. But by far the most common thing to do with your time observation data is to get it into your standard work template, which is by far the most powerful tool in your Lean toolkit to document, measure, analyze, improve, and control that process. So in Excel, let's open the tab for the Systems to Win menu in the ribbon bar. Select the Systems to Win Templates button, scroll down, select the standard work template, and click the button to open it. And like every Systems to Win template, it opens up to a help worksheet. And if we scroll down, we find the instructions for this template. And if we follow the instructions in the online training, we will have already filled in our default units of measure and other data in the pink double border cells on both the help and standard work sheets.
If you haven't done that already, then stop this video and go follow the instructions in the online training. If you have, then you're ready to enter your time observation data.
So let's get started. First, let's look at the pop-up help for this very first column, which tells us that every row needs an operator number assigned to it. It also tells us we can scroll down to see the list of operators. Who are these guys? And here's a trick. Rather than scrolling, if we hover our mouse over that little anchor link, that'll tell us, hey, if you click me, I'll take you directly to the operator table. So we click it, and it takes us directly to the table where we can optionally define names associated with our operator numbers.
This is optional, right?
Yes, this whole table is optional. And if we click the pop-up help for this next column, it says we can even optionally assign operator levels. So if it's blank, it's going to assume everybody's working at 100%. But if you got a disabled person or a trainee that you're observing, maybe they're not working at 100% level. Or maybe you got a superstar who's 10% better than everybody else. So for example, let's say that we're observing Jimmy Newhire, who we figure must be at least 10% slower than the other guys who've been doing it for 15 years. So when we scroll up and enter the operator number associated with Jimmy, which in this case is operator 2, then the efficiency level for each operator automatically comes over associated with that operator number. Now remember that the level was blank for operator 1, and for any operator where the level is blank, it's assumed to be 100%. And if all of your operators are always the same, then just hide that column.
Remember, this is Excel. Use everything you know about Excel.
Now if we look at that pop-up help again for operator, notice that I changed it as part of making this video to remind you that the steps for each operator must be all together. So if we have operator 1 doing the first 2 steps, and then we have operator 2 do the third one, that's fine. But if we change this first operation to be operator 2, then that's not okay. All steps for each operator need to be right next to each other, even if you need to move entire rows, which we'll teach you how to do in a later video when we get to improving the process. Now the last thing in the pop-up help says that for a process performed by an external operator, we're going to enter a -1, and that will appear as an X.
What's an external operator again?
That might be a step that's performed by someone who's not dedicated to this process. Maybe a materials handler does something, or an inspector, or the shift supervisor. So in the op column, we enter a -1. And when we press the Enter key on our keyboard, that -1 gets magically converted into an X, which tells us that that step is performed by an external operator. And we will learn more about how to handle steps performed by an external operator when we get to the advanced training for special situations. But first, let's cover the basics. Now that we know how to enter an operator number, your next step is to observe process times. And before you go sending your people out there in the field, you want to ensure that every one of your observers are well trained in every aspect of process observation training.
And by far, the most important part of process observation training is to understand the definition of a work element. It is the smallest increment of work that could be handed off to another person.
So back on our standard work template, when we click the column header for a work element, the pop-up help repeats what you learned in the online training. A work element starts and ends with a breakpoint where work could be handed off from one worker to another. For standard work analysis purposes, that's the level of chunking that we're looking for. In other words, there's one row per work element. If an experienced observer was out there observing Sally and she's doing a full minute's worth of work, but he notices that there were 3 different points that could have been breakpoints. She could have handed it off to someone else. That would have 3 work elements, each with Sally's operator number. If Bill was out there working on something for 10 minutes that could not be handed off, that's 1 work element. Now, if you have a really complex work element, later on we're going to teach you how to insert a link icon that you can use to create hyperlinks to related documents that might contain 6 pages of details for a really complex work element. But this is not the place for that level of detail. For standard work analysis purposes, the correct level of detail is 1 row per work element. And if you get that wrong, then at some point you're going to need to start over and re-observe that process again, this time paying attention to the very first instruction that says,
Novice observers need to be paired with experienced mentors.
So back on our standard work training page, we see that we have 3 optional ways to gather our time observations. By far the most common is to use a stopwatch, and we'll show you how you can enter your time observations directly into your standard work template in just a moment, but it's even more common to use a printed time observation worksheet, which is a Word, not Excel template, which is designed to be printed, taken out there with a clipboard and a pencil and a stopwatch to the Gemba, the place where the work's actually done, and then you'll later transcribe your observations to your standard work template later.
I'm assuming we can also use the other process observation worksheet. Can it also import from a phone or a tablet?
Sure. If it can't export to Excel, what can it export to? So then you're able to just copy and paste your data. Instead of regular paste, you do want to use paste special so you don't mess up the formats when you paste it. And you want to paste just the observations. Let your template do the math.
I see that it also supports video time observation. I certainly wouldn't recommend that for everything, but there are times when that makes sense.
So when you're recording your video on your camera, turn on the feature to show time on the video. So on the sample page of our template, there's already some sample data for video time observation. So as we're looking at our video recording, we judge that we see a break point where work could be handed off. So we pause the video at that point and look at the time stamp. And then we go select the cell for the end, and we enter the time that we saw on the video timestamp. And when we click Enter, notice that it auto-calculates the time since the last breakpoint. Now, if our time observation session gets interrupted, we can always start a new start time, and it'll just pick up the calculations from there. Notice it is important to enter the time in the correct format so Excel notices that it is a time format of data that you are entering.
And if we're not using video time observation, then we can simply hide those columns, right? So that we have a less cluttered workspace.
That's right. And of course, most of the time you're not doing video time observation. You're either using a stopwatch or a handheld device, in which case you use this time observations section. And you can hide or unhide the number of columns you need for your desired number of observations. And notice that unlike that Kludge template that you've been struggling with, on this template, every one of these calculations will automatically adjust so that any row can have anywhere between 1 and 10 time observations. The fastest repeatable time is the time that's usually recommended by most lean experts for standard work. It also calculates the median average time as well as the mean average time. And even though it's discouraged for lean process improvement, we do have some customers who appreciate the feature to be able to maintain a database of the standard times that it usually takes to do common work elements. And we even support that, but usually not. Usually you're going to want to hide that column.
So all of those times are calculated and available to us. How do we choose which ones we want to use for our analysis?
You select this pink cell at the top of the time column and then use the drop-down list to choose repeatable, median, average, standard, or video time. And at any time, you can switch between them. Are you starting to feel the power of what you got here?
Yeah, let me do it. So at any time, my people can use this drop-down list, and then they can choose from any of these 5 types of time observations, and I can trust that the math is right. That's really, really useful. Can we go back to the template? My eye keeps getting drawn to that frequency column. If that's what I think it is, let me hover my mouse over that help link. Yes! Out of cycle work. So if I click that link, it takes me to the training. Yes! This is the single biggest problem we have when we try to analyze standard work.
You and everyone else. It's relatively easy to analyze things that happen every single run cycle, but every process also has things that happen less frequently, like maybe setups and changeovers, or inspection twice a shift, or palletizing every third batch. And those things affect your work time available. They affect your costs. They affect your ability to meet your schedule. And out-of-cycle work is by far the most difficult thing to wrap your mind around for anyone who's trying to analyze standard work. And that's what your frequency codes do for you. We will explain what these 4 columns in the blue shaded cells do when we get to the analysis section. But for now, let's finish the training that's relevant for time observation. If we click the column header to get the pop-up help, it tells us that there are 3 ways to use the frequency field. 95% of the time, you're just going to leave it blank. And that's going to assume that that step is happening at the frequency of the run cycle. So right now, in this example, every part is being inspected every run cycle. So why is the frequency adjustment factor 0.1 instead of 1? If we're doing this every single time, it should just be multiplied by 1, right? Well, actually, the run cycle is observed time divided by quantity per run cycle. So if we scroll down to take a look at the quantity per run cycle that we entered in the pink cell in our initial data, we notice that in the sample data, we're running a machine that stamps out 10 units per run cycle. If we were only making 1 unit per run cycle, then sure, you would be right. Leaving the frequency column blank would assume the run cycle, which would result in a factor of 1 rather than a factor of 0.1 because we're making 10 units per run cycle. But what if our team designed a Six Sigma quality improvement project to give us the confidence to only need to inspect the first and last part in the batch? The calculations will tell us how would that affect our work time available, our costs, our ability to meet our schedule.
Oh my gosh, my prayers have been answered. So where do we go to define our own frequency codes?
Whenever you see one of these anchor link icons, that means it'll take you somewhere within the same workbook. In this case, if we click that anchor link, That takes us to the place on this page where you can define your own frequency codes. Important note, do not edit those first 3 frequency codes for run, batch, or shift, because we've already done some fancy calculations that you're going to need. But right beneath them, you can enter an unlimited number of your own frequency codes. If your leaders have defined commonly used frequency codes, it just makes it easier for your users to choose them from a drop-down list. But not everyone has such good leaders, so there's one more way to use the frequency column. In addition to leaving it blank or using the drop-down list, you also have the choice to simply enter a number, and that will be for the number of times per work time available. In other words, per whatever unit of measure you put in for work time available down in this pink cell down near the bottom. Usually shift, maybe batch, maybe month, maybe lunar cycle, whatever unit of measure you chose. For example, rework happens approximately 15 times per shift, so we just put in the number 15. Or mixing ore happens 3 times per shift, so we just put in the number 3. So in those 3 ways, your frequency adjustment factors allow you to analyze not only things that happen every single run cycle, but also a powerful way to analyze those things that happen less frequently. So let's finish with some training for some special situations that really aren't so special. They're pretty common, really. The first one is external operators. In other words, a step is performed by someone other than the usual operators. So maybe the inspector or a materials handler. We already learned that in the first operator column, we're going to enter the -1, which will appear as an X for external operator. What we didn't tell you that after entering -1, as soon as you hit enter, not only will the operator field turn to an X, but all these calculations go away. And that's because our standard work analysis for this process would get really messed up if we were to include steps performed by an outside operator. But there's one really important exception, and that is if the regular operator, in this case operator 1, for that entire 6 seconds, or even a part of it, has nothing better to do than to stand around and wait for that external operator to finish doing what they're doing. Then we add an extra row for that operator, and that wait time is part of the calculations. And while we're doing our time observation data entry, we might as well select the value add code for wait time so that that step is highlighted in red, because waiting is always one of the forms of waste that we want to identify and eliminate. And Kathy, what else did we learn earlier in this video that we're going to want to deal with right away?
All the steps performed by an operator need to stay together.
That's right. And right now, some of the steps performed by operator 1 are interrupted by that step performed by the external operator. So how do we fix it? We use Shift down and move to move the entire row so that all of the steps performed by the operator stay together. Now the next special situations that are pretty doggone common are processes that involve machines.
Yes, I have such difficulty trying to get my people to understand that standard work analysis is all about the operator, not the machine.
That's right. Machine time is so unimportant that it doesn't even get recorded on its own row. Machine time gets recorded on the same row as the step that the operator performed that launched the machine. Now, if the operator has nothing better to do than stand around and watch that machine, then wait time does get its own row. Standard work analysis is all about what the operator is doing. We really don't care about the machine unless the operator is waiting for it, or the unusual circumstance where we notice that machine cycle time is getting too close to comfort or greater than takt time. And that brings us to our third special situation. If any machine is greater than your takt time, then the first thing that you might do is use your machine balancing template, which might come up with some ideas. If you still have a problem, you got two choices. You can either divide the work between two work centers. Each one has its own operators and its own machines. That means you've doubled your tack time. You got more time available. Or option two, which brings us to the fourth unique circumstance we're going to talk about, is that you have one operator or team of operators running multiple machines. And the only thing that's really important to handle that is to change the quantity per run cycle. Let's do it together. In our template, let's scroll down to this bottom section where we had entered our default data in the pink double bordered cells. And notice that as of right now, we have a quantity per run cycle of 1 unit. So that happens to be that our tack time for our shift is the same as our tack time for the run cycle. If the operator is running two machines at once, that means we have a quantity per run cycle of 2. And when we press the Enter key, notice that tack time will stay the same, but tack time per run cycle doubles. In other words, customer demand didn't change. We still need the same number per shift, but we have twice as much time per run cycle because we're making two at once.
And then my people will ask me, well, what if the machines aren't identical? What if the same operator is running the old machine that makes 2 at a time and the new machine that makes 10 at a time? What do I do then?
And the answer is that we've already answered that question. You just enter your quantity per run cycle, in this case 12, and then you enter a comment somewhere to explain where did that number come from.
And then my people will ask me, what about machine time? If two machines are running simultaneously and the old one takes longer than the new one, what number do I put in for machine time?
And the answer is that it really doesn't matter. You could illustrate the combined machine time, the time any machine's running, or just leave it out completely. You just focus on the operator. Remember, the only thing that matters for this analysis is that you get quantity per run cycle correct.
Remember, for standard work analysis purposes, machine time is relevant only to the extent that it affects the operator.
So let's finish this training video with one last special situation that is commonly encountered when you're doing process observation. And that is that you might have multiple operators following each other in a U-shaped work cell, each one doing the same thing. And to handle that, you could put all 5, 6, or 10 operators on the work instructions and repeat the same thing over and over again. But it's more effective if you just assign operator 1 to perform all the steps that each operator does, and then manually override the worker's actual cell. Let's do it together. Now for this example, we hid a bunch of rows so that you can see both the top and the bottom together. And notice that the blue cell at the top of the operators column is a subtotal. And that's the same number that we see for workers actual down here at the bottom. And if we enter a second operator here, then the subtotal changes at the top and the workers actual changes at the bottom. But we don't want to do that. The instructions say don't duplicate the steps for each operator, just show the steps for operator 1 and then manually override workers actual. Now don't overwrite the number in the primary cell, because if you do, you're going to trash the formula. There's nothing to prevent you from shooting yourself in the foot if you don't know better. But the right way to do it is to select this cell over here on to the left and enter your override data there. And when you press the Enter key, watch what happens to capacity. And then the final instruction is to scroll up, and in the comments text box, enter the comment that this process is scalable by simply assigning more operators, up to a maximum of how many. And you can rescale that comments text box to any size you need it to be. Did we mention this is Excel, and you can use absolutely everything you know about familiar Excel?
Nice. Thank you.
Thank you.